Welcome to the 2022-2023 Jump into STEM student competition. My name is Dr. Ryan Meyer. I'm a research engineer at the National Renewable Energy Laboratory, also known as NREL, and I'm part of the Jump into STEM management team. This is a short recording describing and providing background as well as additional resources for one of this year's 3 challenge topics. Please visit our JUMPintoSTEM.org webpage, where you will find all information related to the competition, rules, submission requirements, as well as information about the challenges. The following recording discusses It's Electric, electrifying U.S. buildings. The U.S. has a long-term goal to decarbonize the electric grid. This includes targeted timelines for providing carbon or pollution-free electricity, as well as objectives for reaching net zero carbon emissions for all US buildings. Now, this is a very lofty and long-term goal, and it will require several market transformations across multiple sectors. Yet buildings will play a critical role in helping achieve these objectives. One step in this process is that we need to eliminate the burning of all fossil fuels in our buildings and transition them to electricity. This concept is known as electrification. Many of our buildings directly burn fossil fuels. Those are propane, natural gas, fuel oil, and there are others, for a number of reasons. The most common reasons include space heating equipment. Those are your furnaces, boilers, water heaters, as well as a number of other appliances. Common household appliances could be gas ovens, stoves, clothes dryers, just to name a few. Now, how large of an effort is this to transition all of these appliances and all these pieces of equipment to use electricity? In 2021, nearly half of all energy consumed by the residential and commercial building sectors combined came from directly burning fossil fuels. Overall, this equates to about 20% of the entire amount of energy consumed by the US annually. Needless to say, this is a large endeavor. Space heating itself is responsible for a large share of fossil fuel burning in our buildings. More than half of commercial buildings use a fossil fuel as their primary space heating source. That leaves approximately 30% relying on electricity in one form or another. For our homes, natural gas accounts for almost 70% of all energy consumed. The majority of this is going to both space and water heating. And here we see only about 14% of space heating provided by electricity. This is our motivation for this year's Jump into STEM It's Electric challenge. Buildings must find innovative and effective ways to eliminate the burning of all fossil fuels. Students, such a substantial market transformation that stretches across all residential and commercial buildings will need numerous innovative solutions. And these solutions must achieve widespread adoption so that we can reach our objectives of a carbon-free grid. So now let's provide a little more guidance on a few specific topics that might pique your interest. Heat pumps. Yes, let's talk about heat pumps. Have you heard of them? Okay, so what are heat pumps? Well, this will likely be a question on one of your exams over the next few years, if it hasn't already. Heat pumps are most simply air conditioners that can run in both directions. It can cool and it can heat. Now, what's more interesting with regard to this proven technology, especially for building electrification, is a heat pump's high performance. See, heat pumps, they do not create heat by, say, burning a fuel. Instead, heat pumps move heat from one location to another. They can move heat from the outside air into a building, commonly referred to as air source heat pumps. They can move heat from water into a building. These would be called water source heat pumps, or even, as the name implies, yes, ground source heat pumps. These move heat from the ground into our buildings for us to use. And most notably, heat pumps are anywhere between 2 and 4 times more energy efficient than a, say, furnace or gas boiler. So not only do they provide us with an opportunity to electrify, but we can do it efficiently. Now, heat pumps are not a new technology. And as we look to the future, air source heat pumps will likely be a primary candidate to replace the vast majority of space heating systems in both our homes and businesses. But there's a catch. You see, a heat pump moves heat. Now, let's think about this. When do buildings typically need heat? When it's cold outside. Are you following me yet? It may seem a bit counterintuitive that these devices move heat from really cold air outside and turn it into something useful and warm inside. And this is true. And in fact, for this technology to be adopted, and specifically widespread adoption across the entire US, this aspect is an important challenge. So within the realm of heat pumps, there is an opportunity to solve existing market barriers that currently limit widespread adoption of the technology, especially in the warmer climates. But there is also significant opportunity here to advance the technology and improve its operation in colder climates. Another important consideration is that we need our space heating equipment to provide heat on the coldest day of the year, for sure. But more than 80% of the time, we do not need that much heat. In fact, we need some fractional amount of that heat. The idea of picking out an ideal sized piece of equipment that specifically matches the building's heating load, this is known as right sizing. When we look at heat pumps, right sizing and then coupling this concept with other energy efficiency strategies to, say, improve a building's thermal performance, this needs investigating and solving. We need solutions that address both of these so that we can electrify our heating needs, but do so in an energy efficient way. Now, you may recall from an earlier slide, I did note that heat pumps can also provide water heating. Market offerings are growing every day to replace gas-fired or even electric-resistant water heaters. Residential applications have seen greater growth in recent years, likely attributable, at least in part, to the fact that water heating energy is a proportionally large part of the residential energy sector's consumption, especially when you compare that to the commercial sector. So even here, opportunities exist to improve the technologies and look for ways to address other market barriers, an easy example being cost. Now let me back up. This is not a heat pump challenge. So let's point out another concept worth noting. In addition, you will likely find many other topics, and I encourage you to do so, but I'm limited here to a little bit of time in this recording, so I'll focus on one more topic. So far, we've talked about the equipment, the heat pump, the appliance. But guess what? In order for an electric version of that appliance to work, we need electricity. We need an electrical connection. This in and of itself is a substantial barrier for us to achieve our electrification goals. So consider that the majority of homes in the US were likely built before 1970. At that time, the typical size of a home's electrical service was maybe 100 amps or more likely less. Now, the electrical panel itself, this is sized based on the equipment and the appliances the home was built to have. In other words, if the home was built to have a natural gas furnace, there is likely no infrastructure in place to just swap it out for a heat pump. This can include wires, but it's also the overall electrical service and amperage available at the breaker box. Now, of course, you might think to yourself, yeah, well, let's hire an electrician. Yes, this could work, but consider for a moment the expense, the cost. Not only are we looking at the purchase of additional equipment to replace our fuel-fired equipment and appliances, but now we are making electrical infrastructure upgrades. And let's be frank, this is likely not economically justifiable for all. Solutions here can not only serve those with resources if we are going to decarbonize the entire grid. So students, we are looking for you to develop an innovative solution that will address electrification in our buildings. You can focus on any aspect related to transitioning buildings away from directly burning fossil fuels. You could consider this problem at an individual building scale, or even go larger and consider communities, cities, or regions. But this is your challenge. Now, the following 2 slides contain links to various resources of the topics discussed in this short video. These are meant to help point you in the right direction for finding a problem that you and your team want to solve. Please keep in mind, this short list of resources is not exhaustive. These are here to provide you context and a starting point for your own investigation. You could also look to the challenge description itself, where you will find additional references that are cited. If students or faculty have any questions, please feel free to reach out to the Jump Into STEM management team. Thank you and good luck.